All right, what does this look like in R? Running the t-test is pretty straightforward. Here's a data set. It comes with a tutorial called Prestige. The two variables in it are prestige, a rating of occupational prestige, and then variable called group. So we're basically predicting prestige from group. The piece var equal true. I'll talk about that in a little bit when I talk about assumptions. Tells us we're doing a two-sample t-test. It gives us a t-value, degrees of freedom, and a probability. So the probability here is 0.04. It gives us our confidence interval, and you can see our confidence interval is roughly what we calculated. There's always, some rounding. There's always some rounding issues, so we may be off by, in the 100th place a tiny bit here. One thing to note here: that confidence interval does not include 0, so we reject the null hypothesis. Probability. The other way to approach these conclusions is to use the probability value and ask whether that's less than 0.05, which it is in this case. It'll always be the case that if your probability is less than 0.05, your confidence interval doesn't include 0, and vice versa. They are linked together in that way. The effect size, and as I noted here, this probably didn't need its own slide. The effect size comes from a package called LSR, written by Danielle Navarro, who is also the author of the free text that's optional for this course. The command is coensd, and it looks just like the t-test. The data set $, dependent variable predicted by data set $, independent variable. You can see here we get about 0.41, again, a small rounding error, I think, when we calculate it by hand. One thing that is, well, I take that back. One thing that I thought was gaining traction a while back was getting confidence intervals around effect sizes. I still think that this is valuable because we get some sense of how big or how small an effect could possibly be in the population. Here we just use a package called mbes, which doesn't actually stand for anything. The command is ci.smd. SMD stands for the standardized mean difference, so that's your d value. We feed it our two sample sizes. I don't think the order matters here. And you can see it gives us now a confidence interval. This is actually a confidence interval for various reasons that we can't calculate by hand. We can kind of approximate it, but it doesn't use the t distribution. It uses what's called the non-central t distribution, which is not something that you can look up values for particularly easily. So you can see our confidence interval goes from about 0.02, a very, very small effect, to about 0.80, which would be a much larger relative effect. So what this confidence interval is telling us is it could be that there's hardly anything there, or it could be a really big difference. So we see here that we don't have a lot of precision in this result. I like the context that these confidence intervals give us. This is telling us, well, how much can we really trust this result? And well, there may be an effect, but it might not be particularly big.